Class 12, 5th chapter, Continuity and Differentiability, exercise 5.2. So in this heading, there are 10 questions. And in the previous video, we have solved and proved that the ninth function is not differentiable at x equal to 1 in using one method. So in this video, we will apply another method to prove that this function is not differentiable at x equal to 1. So let us read the question. Prove that f of x is equal to modulus of x minus 1, where x belongs to the set of real numbers, is not differentiable at x equal to 1. So the function is given to us and the point is given. We have to prove this is not differentiable at this point. So how do we prove that this is not differentiable? For that, let us know when the function is differentiable at a point. So the function is differentiable at a point x if left hand derivative is equal to right hand derivative. So if the left hand derivative is equal to right hand derivative, the slope value in the left must be equal to the slope value in the right. So limit h tends to 0, f of c minus h by h must be equal to limit h tends to 0, f of c plus h minus f of c by h. So if these two values are equal, we say function is differentiable at a point x. So we have to prove here that it is not differentiable. So if it is not differentiable means left hand derivative must not be equal to right hand derivative. Right? So let us solve left hand derivative and right hand derivative, and we have to get different answers because they have mentioned here that it is not differentiable. Once we will revise what is modulus function so that we will not be stuck in the proof. So modulus function is basically a distance function. Distance function. That is, you find the distance of this x, what value you substitute, distance of x from the origin. So modulus of function is basically a distance of the value x from the origin. So let us select this as the origin O, and this is the real number line. Okay. Now let us select some 2 points, plus 1, plus 2, minus 1 and minus 2. So how do we apply modulus function to these numbers? Modulus of x. So x is usually taken from the domain, the real number line. So let us select x equal to 1. So distance of this point from the origin. So what is the distance of the point from the origin will be 1 unit. Let us take point 2. So distance of point 2 from the origin will be 2. It will be 2 units away. Now let us go for the negative numbers. Minus 1. So what is the distance between minus 1 and 0? So distance is always positive, right? No matter any number you give as an input, the output will always be positive. So it will be 1 unit away. So the distance between minus 1 and 0 is 1. And what is the distance between minus 2 and origin? It is 2. Right? So the distance from here to here is also 2. No matter it is a negative number. So we can come to the conclusion that if I give a positive number, I'll get back the positive number. If I give the negative number, the distance of that negative number from the origin will be positive. Right? So modulus of h is h and modulus of minus h is also h. Yes, then what is modulus of 0? Modulus of 0 is the distance of origin from itself, or distance of 0 from itself. it will be 0 because the point will be here only. There will be no distance covered. So modulus of 0 will be 0. Right? So with this information, let us prove the sum. So left hand derivative, I have written the condition. Now this implies limit h tends to 0. So here the point that we have selected is x equal to 1. So we will substitute c equal to 1 here. So if they have given 2, you have to write 2. So this is the point that we have to check. So let us write 1 minus f of 1 minus h divided by h. Now how do we get the value of f of 1 and f of 1 minus h? From the function. So we know f of x is equal to modulus of x minus 1. So if I want f of 1, this will be modulus of 1 minus 1. 1 minus 1 will be 0. Right? And what is f of 1 minus h? It will be in the place of x, we have to write 1 minus h and this minus 1. So in the place of x, we are writing 1 minus h and the minus 1. Now this will be equal to plus 1 minus 1 will get cancelled and we will get modulus of minus h. So let us substitute here. This implies limit h tends to 0. F of 1 is, we'll do one thing, we'll write here once again, modulus of 1 minus 1 divided by modulus of 1 minus h minus 1 divided by h. Now we have already simplified it, right? So we will write modulus of 0 minus modulus of minus h divided by h. Now this implies limit h tends to 0. So just now we solved modulus of 0, distance of origin from itself is 0, minus distance of any negative number from the origin is positive. So we will get h divided by h. Now this implies limit h tends to 0, 0 minus h will be minus h by h. Now this implies limit h tends to 0 plus h by minus h, it will always be 1 and we have minus here, so minus 1. Now limit of a negative value will be, minus 1. So therefore we will write limit h tends to 0, f of c minus h divided by h is equal to minus 1. So this is our left hand derivative. Now we will solve for right hand derivative. So limit h tends to 0, f of, in the place of c we will write 1 plus h minus f of 1 divided by h. Now how do we write the value for f of 1 plus h? Using the function modulus of x minus 1. So f of 1 plus h will be equal to 1 plus h in the place of x and minus 1. Now this will be plus 1 minus 1 will get cancelled, will get modulus of h. And f of 1 already we have proved, f of 1 which is modulus of 0. So limit h tends to 0, this implies in the place of f of 1 plus h, we will write once again the step 1 plus h minus 1 minus 1 minus 1 divided by h. Now this implies limit h tends to 0. This will be modulus of h minus modulus of 0 divided by h. Now this implies limit h tends to 0. Modulus of h is equal to h, right? Even if h is positive or negative, the output will always be the positive distance. So we'll write h, and distance of origin from itself is 0 divided by h. Now this implies limit h tends to 0, h minus 0 is h by h. Now limit h tends to 0, h by h will be 1 and limit of that constant value will be 1. So therefore limit h tends to 0, f of c plus h minus f of c divided by h is equal to plus 1. So left hand derivative is not equal to right hand derivative. We say that the function is not differentiable at x equal to 1. Therefore, the function modulus of x minus 1 is not differentiable at x equal to 1. Hence, proved. So this is the graph of f of x is equal to modulus of x minus 1. So I have already explained in the previous video, but let us understand once again. So in this graph, modulus of x minus 1, so we have to check that left hand derivative is not equal to right hand derivative at x equal to 1 at this point. At point equal to 1. That's why we substituted 1, right? Now, when we approach from the left side of the domain, the slope value will approach minus 1, and when we approach from the right side of the domain, the slope value will approach positive 1. Right? So here it is minus 1 and plus 1. Though here 1, the numerical value is same, but the sign is different. Why? Because if a straight line is falling down, then we say that the slope is negative, and if it is raising upwards, we say that the slope is positive. So that's why this is minus 1 and this is 1. So since the values are different, signs are different, we say that the function is not differentiable at x equal to 1. So here we completed 2 methods. Now for the 10th one, I will use the method to